Imagine cruising down the highway in your car, completely at ease, knowing that the vehicle you're in is equipped with the latest technology to ensure your safety. Now ask yourself, what if that wasn't the case? What if the car you're in lacked the necessary advanced driver assistance systems, commonly known as ADAS features? The answer is rather grim. The absence of these features could result in catastrophic accidents. Our world is continuously evolving, and the same applies to the automotive industry. In essence, there are 6 levels of automated vehicles, starting from level 0, which includes no automation, to level 5, where the vehicle is fully automated. Each level represents a significant leap toward the future of transportation, integrating technology into vehicles in ways that were once thought impossible. The heart of this project lies in the components used: a Raspberry Pi camera, V2, Raspberry Pi 3, Model B, Arduino Uno and Arduino Mega, ultrasonic sensors, motor driver, MH speed sensors, and the use of the Genie IDE and Arduino IDE were the main hardware and software employed. The project's objective was to avoid collision situations through Wi-Fi communication between 2 vehicles. A sequence diagram was developed as a visual representation of the logic used by the vehicles, contributing to understanding how they operate. In terms of communication, 3 methods were utilized: serial bus, 521 communication for wired communication between the microcontroller and the microprocessor units, binary communication through digital pins between Arduino and Raspberry Pi to control the motor's speed and direction, and Wi-Fi V2V communication to allow the vehicles to be aware of other vehicles in range. The project was put to the test in 5 different scenarios, ranging from keyboard driving to collision avoidance. Each test aimed to evaluate different aspects of the vehicles, such as lane tracking, braking system, obstacle detection, and communication. At the end of the day, what were the results? The 2 vehicles were able to remain in their own lanes, detect obstacles, and interact. However, the goal was not fully accomplished as the absolute communication was not achieved. So what does this mean for the future of vehicle safety? It shows a promising future where technology and vehicles can work hand in hand to ensure the safety of passengers. However, there is still work to be done. To accomplish absolute communication, a DSRC device should be implemented along with a GPS. This will allow for autonomous features to thrive. While the project exceeded the estimated budget by approximately $600 Canadian, the invaluable insights and the significant steps taken towards a safer future in transportation make it a worthy investment. The journey towards safer roads continues, and every step taken brings us closer to that reality.